Chapter 3, Molecules, Compounds, and Chemical Equations. Here's an interesting question. How many different substances exist? Big number, huh? So we know that there's 91 naturally occurring elements, but then you can combine those in different ways. And even just combining carbon and hydrogen, because you could have 2 carbons and 6 hydrogens, or 2 carbons and 4 hydrogens, or 2 carbons and 2 hydrogens. There's all these different possibilities. There are a lot of different substances. We are familiar with lots of different things, even if they're not pure substances. We've got food that we eat that tastes different than other food that we don't like. There's paper products and clothing, and there's gases and metals and all sorts of different things. And they all have very, very different properties, which is a good thing, because you wouldn't want to have your car be made out of tissue paper, right? It wouldn't stand up in the rain very well. So this great diversity that we see is it's a result of the ability of atoms to combine with each other to form compounds. So let's look at 2 compounds composing that have hydrogen and oxygen in them. So hydrogen and oxygen can combine to form water. In water we have 2 hydrogen atoms and 1 oxygen atom. And when these 2 elements combine, their properties change dramatically. Hydrogen is a flammable gas, very low boiling point. Oxygen, while not technically flammable itself, it is the necessary component for combustion, so fire doesn't occur without oxygen. You take those 2 things and you combine them in water, and now you have a liquid with a high boiling point, and not only is it not flammable, it's used to extinguish flames, right? So combining 2 elements to form a compound, completely new properties. We talked about the law of definite proportions. When we have a mixture of oxygen and hydrogen gases, the proportions could be anything. It could be 5-to-1 or 100-to-1. It could be 1-to-1. But in a compound, the proportions are always the same. And the reason that the proportions are definite is that those compounds always have the same number of atoms of each element. So water has a definite proportion of hydrogen to oxygen. Here we have illustration of a mixture and a compound, same elements. Here's a balloon containing hydrogen gas and oxygen gas. You touch that to a candle and it's going to make a very large boom, probably enough to lift the ceiling tiles in here for a regular sized balloon. Very, very flammable. There are different particles here. There are the hydrogen molecules and the oxygen molecules. They're different particles. In water, which is a compound, not a mixture, all of the particles are the same. They each have 2 white balls and 1 red ball. They kind of look like little Mickey Mouse heads to me. Any questions? It's important to be able to distinguish between a mixture and a compound. In a mixture, you have more than 1 kind of particle. In a compound, all the particles are the same as each other.